that introduction, Greg. I appreciate the opportunity to come and see everyone today. It's wonderful to see such a large group of people. Since you had trouble with this, I'm going to have real trouble, right? Not that button. There we go. Okay, everybody here today probably rode on an interstate highway, I'm guessing. Unless you happen to live on campus, everybody in Houston goes on an interstate almost every single day. So we're all familiar with this technology. It was first started in 1920, the first plans. People think it was Eisenhower, but it was actually well before him. So what's great about the interstate? Works great for us today, sort of. But we need Interstate 2.0 with new technology. Faster, cheaper, greener, and safer, and more entertaining. But I couldn't fit all that on there. All right. That wasn't the button. There we go. There's some slow. So I'm going to talk to you today for only 10 minutes. It's a huge topic. I'm going to focus a little bit on reminding everybody what the interstate system is and some key facts about it. We're going to talk about new vehicle adoption, electrification, and autonomy. We're going to hear more about autonomy later, but we're going to talk about it on the freeway. Challenges and improvement opportunities. Everybody who drives on it and has an hour to think about it every day has their own pet peeves about it. We'll talk about some of the real opportunities to make it much more useful. We're going to talk about an integrated roadway concept that's being tested by Siemens, a German electric company. And we're going to talk about what I think technology is needed to adopt that concept for US. Might happen, might not. We're seeing a lot of innovations happening in this space. Okay. Interstate highway system, 48,000 miles of concrete, covering about 800 to 1 million acres. We don't have exact numbers on that. The states actually own the right-of-way. That 800,000 acres, 800,000 to 1 million acres, could produce, if we put solar PV on it, 8% of the US consumption of electricity. So we're using land right now to hold up concrete and not do other stuff with it. There's an opportunity there. It carries 43% of US truck miles. Okay, that works out to about 66 billion miles a year. The majority of the highway use is in town. So about 2/3 is urban, 1/3 is suburban. Keep that in mind when we think about how we're going to use electric vehicles on that road. Let's go to the next. Yes, that worked better. What we're seeing with battery electric vehicles. Anybody here besides a few of us we have a few who are driving electric vehicles. We're going to start seeing many more electric vehicles coming into the marketplace because electric battery costs as a proportion of the cost of a car have come down dramatically. Bloomberg News has estimated by 2023 there will be parity for a medium-sized car. Capital cost for an internal combustion engine versus capital cost for a battery engine will be the same. But electricity is way cheaper than gasoline. So the actual cost of operating your vehicle as an electric vehicle will be considerably less, and we're going to start to see that driving a large increase in the number of cars that are sold as electric vehicles. Trucks, not so much. Why not? Because trucks require a lot more batteries, and batteries are heavy, and it causes an issue with the load capacity. Talk about that next. Okay, in order to have an electric vehicle, you have to fuel it. Most fueling for electric vehicles is going to be done in its domicile. So if it's a truck that's at a terminal, it will be fueled at the terminal, charged at the terminal. If it's at your house or your apartment, it's going to be charged at your house or apartment or at your workplace. However, on the interstate, you don't have a house or an apartment or a domicile. You need charging. And you can see 3 major charging networks already in the US that are located along interstates. The challenge with interstates is we need faster charging so that we can put those vehicles out. And the problem with faster charging is, you'll notice we have CenterPoint here talking about their grid. As you have higher and higher rates of charging, you put more and more stress on the grid. So what that requires is some method of storing energy to feed into those charging systems, which means even more batteries. And that's a challenge with making this transportation transition is bringing those batteries in place. Next, please. The other major technology that's happening is the change in who drives the truck or who drives the car. So autonomous vehicle adoption over the last 3 or 4 years, we've seen technologies coming out. I believe today we actually have highway trucks that are being driven autonomously. They're not publicized because people don't want to have, truck owners don't want to have people vandalizing or causing troubles with those trucks. They're often being done with safety drivers, but increasingly we're removing safety drivers from that segment. Urban cars, much, much more difficult. People are pretty finicky about how they want to be driven around. A box in the back of the truck, not so much, right? So we're going to see urban cars and taxi services later, and we're going to hear Shola talking about a package delivery service urban. Urban is hard. There's a lot of complexity. What's driving all of this change? Okay, according to the American Trucking Association, it costs almost $2 a mile to drive a truck down the road. 2/3 of that cost is the driver and the fuel. This is diesel fuel. Diesel fuel is expensive. Electrons are about 20% of the cost. So electrification is an important move for trucks to move toward. Driver costs are 40% of the cost of driving, going down the road. So if you can reduce that, there's a very significant improvement in value. Okay, let's go to the next. What are the adoption challenges for these two new technologies, electrification and autonomy? One of the biggest problems is the availability and cost of batteries. Currently, manufacturers, OEMs who are wanting to make electric vehicles find that they're having a shortage of battery facilities. There are very few EV truck models available to purchase today. If you called up Peterbilt and said, hey, I need an electric truck, they're going to say, hey, talk to me in 5 years. So we have to get batteries out so that we can build these pieces of equipment. Because of the cost of those, the costs of the vehicles are high. And we're going to have to work on grid power capacity to provide high-speed charging, megawatt or 2 megawatt scale. That's challenging for grids to put up. The other last piece here, we have to have public acceptance of EV and autonomous vehicles. Generally speaking, we find that if you have a technology that is 30% better on some dimension or set of dimensions, it becomes rapidly adopted. We already know that the operating cost and the ease of use and the low maintenance requirements of electric vehicles is driving that. We know there's a huge savings to be had in reducing the cost of drivers. So those weights are starting to move people toward acceptance, and we're going to start seeing very rapid adoption of these technologies. Moving forward to the next, what are the problems that we still have remaining, or what opportunities are there? Can I go to the next slide? Thank you. Because we have to have batteries on board as well as on land in order to provide the charging, that wastes money. We lose payload because of the battery weight in trucks. There's time wasted in charging. There's a whole bunch of time in our interstate where we hardly use them. Anybody driven on the interstate at about 3 o'clock in the morning? It's not very much traffic there. We have human limited driving capacity. How fast can you drive? I know when people go to Dallas, you want to drive 90 because everybody else is, but you're not supposed to because it's not safe, right? But what if we had autonomous vehicles that could drive at 140? Would that be interesting? Potentially. I'm seeing some grimacing over here. Okay, not today, but maybe in the future we'll have that capability. We have 800 to 1 million acres of land that is doing nothing but holding up concrete when it could be generating revenue by making electricity. And we have a failed fuel tax revenue model, meaning that we're going to bust our highway transportation fund mechanism because we won't have fuel taxes. EVs don't pay fuel taxes. So we're going to have to change that in order to continue to have our interstate highway system. What can we do? Deliver power directly to vehicles on the highway. That's a really different concept. We need to integrate AV to have full platooning, full control. And we need to produce and sell electricity from this giant amount of public assets that we have that we're underutilizing. So what might that look like if you put all that together? It might look like this. Something where you have a integrated highway concept, where you have in dedicated lanes, autonomous high-speed electric vehicles like cars traveling as fast as you really want to go to Dallas. That's 20 years down the road, folks, not coming in the next 5. You want to have autonomous electric trucks powered by wires on the road so you don't have to have batteries in them. That could happen faster. You want to have some type of solar canopy so that you're generating power off of the right-of-way. Maybe it doesn't actually go over the road. Maybe it's just on the shoulders on both sides to begin with. But we need to generate more value out of the land that we have. What does this look like in 3D? Maybe ugly to some, maybe different to others. But if you're riding in that vehicle and you're not driving it anymore, probably you're going to be playing your entertainment systems inside. You're going to be moving under the control of something where it's very safe, very fast, very energy efficient, and very green. So this might be a way that we could look in 20 years or more from now. Next, please. Those technologies are being tested. I've got here, Siemens have tried this for a couple of years. I don't know how to turn this on. Can you run this, please? Okay, technology. There we go. They got some fancy music here too. Okay, it looks like a train, except it's a car, and I'm sure some of the same technology is going to be used here. But for the highway, in my view, this technology is not the right technology to go. There are some changes that we can do that will be making it even more effective and cost-effective. So the last slide I have here, that went the wrong way. Okay. The catenaries are a problem. Those wires have to be replaced about every 10 years, and they're expensive. The pantograph weighs 2 tons on a truck. You can't waste 2 tons on a truck. Why do that then? So we need something that has a U-channel that you can connect like this to take your electricity from, rather than a set of wires that you have to push hard against and grind against in order to make the electrical connection. You need a drone to lift the connection up from the truck rather than a 2-ton large piece that we showed. Solar canopy needs to be really light, composite, strong, able to withstand wind. Energy efficiency is being worked on. Current solar PV is 20% efficient at converting solar inbound radiation to electricity. In 5 years, it will be 30% as a result of changes in materials. Autonomy, faster, closer spacing, requires new algorithms, faster computing capability. And importantly, and most difficult probably for the United States, we have to have a public-private partnership that works with this, and the public part of it is hard. So that's where we need some innovation, right? And everybody who drives on that, using those pieces, needs to have some standards, which is why we set up our nonprofit to help people focus on that. Thanks for your attention.